All right, this is video 1.2. Today we're going to be talking about measuring and constructing segments. Remember that a segment is going to be the part of a line that is between two endpoints. We're going to start off with our ruler postulates, what they call it. Basically what they're saying is that if you have a line and you have points on that line, you can put those points on the line in a one-to-one correspondence with real numbers. What that really means is, like, if you had a number line, you could measure like a ruler. For each point, there's a number that corresponds to it on a one-to-one ratio. So if we use this, we can find the length of a segment by using our ruler postulate. And so the length of the segment is going to be, you take where your 2 points are and subtract them, and then take the absolute value. Here's what I mean. So let's say we had a line, and we had point A, and we had point B. We lined it up with a ruler, got our one-to-one. It was like a number line. So let's say 0, 1, 2, 3, 4, 5, like it's on a number line. So our A right here is correspondent to where our point is. We would say that this is A and this is B. So I'm going to take the number that belongs to those, and I'm going to find the difference between them. You can either say 1 minus 4 and get a negative 3, or you can say 4 minus 1 and get a positive 3. Doesn't matter which way you do it, because you're going to take the absolute value. Absolute value is always going to be a positive number. Whatever is inside your absolute value bars, the answer is going to be positive. So that is looking at like the absolute value of negative 3 or the absolute value of positive 3. Either way, the answer is 3. Okay, so let's try one. Here's my number line. Let's say these are my points on my number line. I want you to find the distance, the length of DC, segment DC. So this is what I'm looking for right here. Now, if we are talking about the measure of something, we're not going to have any line over it. So I want the measure of DC. If we're talking about segment DC, it needs to have the line over it. But I'm not talking about segment DC. I want a number, so there's no line over the top of it. All right? We'll come back to that again in a second. So first I need to find the number that is a one-to-one correspondence. So C is at 2. So I'm going to do 2 minus. My D is about 4.5, so I'm going to say 4.5. Right? Now I could do 4.5 minus 2. Either one of them is going to be the same. That would be the absolute value of negative 2.5. Or if you have your 4.5 in front and you subtract 2, then it would be positive 2.5. But the absolute value says we want just plain 2.5. So the length of DC is 2.5. Now I would like for you to find the length of EF. So I'm going to do my absolute value. I just find it easier just to put them in the order that they're up there. So negative 4 minus negative 1. So my minus together makes a plus. So it's really negative 4 plus 1, which is the absolute value of negative 3. Absolute value of negative 3 is positive 3. You can see that there are 3 spaces in between them. That would be 1, 2, 3. So regardless of which direction you went, there are 3 apart. Congruent segments, we do lots of things with congruency in geometry. So any 2 segments, in this case, segments, that have the same length, we would say they are congruent. Now in this case, remember if we're talking about finding the numbers, we don't put the little line over it. So if we had 2 lines that their measurements were equal, let's say CD and EF, and let's say that they were each equal to 3, we would say CD is equal to EF and they are congruent. But if we're talking about naming the lines or the segments and we said CD and we said EF, where we're not talking about how long they are, an identical measurement, in that case we're going to do congruency, which is an equal sign with a little line, squiggly line on the top. Okay, that means I don't know their numbers, I just know that they're the same. So here I've got these two lines, and the way I copied them, you can note that they are the same length. So in a figure, the way you would say that they are congruent, this is how you say they're congruent in symbols, but in a figure, the way you would say they're congruent is you put a little tick mark like that. That says that this line is congruent to that. Let's say we had another line over here and a line over here. Say those are congruent and all these lines are in the same picture. We could use two tick marks to say that those two are congruent. But that this one, this first red line here, is not congruent to that line because they don't have the same tick marks. So occasionally you're going to need to make a copy of a segment, either from the book or from a paper onto your own paper. And there's a couple of ways you can do that. The first way is going to be an estimation. It's going to be a sketch. So if I tell you to sketch a segment, then what I'm looking for is, let's say we were given a segment that's this long, and on your paper, I wanted you to sketch the segment. You could say like that long. It's not going to be exactly the same length. I mean, that would be closer than saying that that's a sketch or that that's a sketch, because clearly the other two are not even a good estimation of the length of the segment. The other one is going to be to draw one. Now, when I say draw the segment, what I'm wanting you to do is to use a ruler, actually measure the length of the segment from the original image, and then you draw using the exact same measurement onto your paper. All right, so that would be to draw the segment. The third way, which is the better way, is going to be to use a compass and a straight edge. Now, not like a compass like that points north. The compass is going to have it usually makes a little triangle, and it's kind of got a point on one end and a pencil on the other, and a little knob usually on the top. It'll even have a measurement across the center there that will help you to measure lengths of angles and length of lines and stuff. And then you would make little points with it and to get you a perfect size of segment. So a construction is the most precise way to do it, but a drawing is acceptable. I don't have a class set of compasses. Most people don't have a compass, and so rulers are pretty easy to use. So drawing is going to be acceptable, and unless I tell you, a sketch is going to be counted wrong. All right, so I'm going to get out my ruler and I'm going to measure and make sure that things are the right size. So the segment addition postulate says that, remember, a postulate is something we take as true even though we don't have to prove it, that if B is on a line between A and C, then this segment plus this segment is going to equal this segment. That should make sense to you. Given that, if we know two of those three, we can find the length of the third, right? That's the addition postulate. All right, so we are going to use our segment addition postulate, and we're going to practice finding the length of segments. So let's say that B is between A and C. I'm just going to sketch out a little example here. Let's call this A, B, and C. We know that AC is 14, so this is 14, and BC is 11.4, so we know this is 11.4, and we want to find this part right here. I'm going to call that X, because that's the part we want to know. So our postulate says that AB, which is X, plus BC, which is 11.4, is equal to AC, which is 14. I'm going to isolate my X to solve for it. To do that, I'm going to subtract my 11.4. That gives me X is equal to 2.6. Right, so AB is 2.6. So let's do another one. S is between R and T. We're going to find RT. So here's my line. Here's my R, my S, and my T. What I noticed when I pull this up is that I am missing some information from here. What you need to know is that this is equal to 4x, right? So my postulate says that RS, which is here, 2x plus 7, plus my ST, so plus 28, is equal to my RT, which is 4x. I'm going to solve for x, And then I can find what RT is by substituting my x in times my 4. So this is going to be a multiple step. You'll have lots of them like this. So first I'm going to move my 2x over to meet up with my 4x. This is a positive 2, so I'm going to subtract 2x, subtract 2x. I'm going to go ahead and combine my like terms right here. My 7 and my 28 is going to be a 35. So I'll do 35 is equal to 2x. Divide by 2. And I'm going to get 35 halves. I'm just going to leave it as 35 halves. So x is equal to 35 halves. That does not tell me what RT is. I am not finished. I have to take my x and put it in place of the x there in order to find what RT is equal. So RT is equal to 4x. And so we would do 4 times 35 halves. When I multiply fractions, I'm going to put that 4 over 1 so that we can see that it is a fraction. And then I'm going to reduce my 4 and my 2. My 2 would become a 1, my 4 would become a 2. So now I'm going to do my 2 times 35 gives me 70. So RT's length is 70. Now, sometimes that point that is in the middle is going to be in exactly the midpoint, which means that it cuts it in half. So if M of a line segment is the point that divides the segment into 2 congruent segments, so we have AB here. If we have our midpoint M, and this is equal to that, that is a midpoint. There's 2 congruent segments. Then a segment bisector is going to be any ray, segment, or line that intersects the segment at its midpoint. So it could be a point, but a segment bisector, we'll use those occasionally. So the segment bisector might be a line that cuts through right there, and so that you have 2 congruent sides. What's really important then is that AM is equal to MB. So you could say AM plus MB is equal to AB, but you can also say, because they are congruent, that AM is equal to MB, right? All right, so let's use some midpoints to find length. We're going to say that B is the midpoint of segment AC. So let's draw our little line. We've got A, C, and B is the midpoint. So AB is 5x, so this right here is 5x, and BC is 3x plus 4. So we want to find the distance between AB from BC and A to C. So first thing that we're going to do is solve for x. We're going to use our midpoint. So because it's a midpoint, it says it's a midpoint, then we know that those two have to be equal. We can say 5x is equal to 3x plus 4. So I'm going to solve for x, move my 3x over, so I'm going to subtract it over here, giving me a 2x is equal to 4. Isolate the x by dividing by 2, giving me x is equal to 2. Now I'm going to take that and substitute it into each of those to find my AB. So to find AB is 5x. I'm going to substitute my 2 in, so that'd be 5 times 2. So AB is equal to 10. All right, BC is 3x plus 4. I'm going to substitute my 2, so I'll do 3 times 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10, which that should make sense. Remember, it's the midpoint, so it should bisect them. They should be the same length. So now I'm going to do my addition postulate, which says that AB plus BC is equal to AC. If AB is 10 and BC is 10, then AC has to be 20. All right. So when you get to class tomorrow, you'll need to be able to find the length of a segment using your distance formula there with the absolute values. be able to use the segment addition postulate and midpoints to find links. Have a good evening.